let's get started. In fact, before I do a proper start, I'm going to start out like most of the great tech talks do, with an apology. Unfortunately, a lot of you are probably expecting to have a lesson about managing your app's data in Flutter, but unfortunately that presenter had to drop out. So last minute I had to come in, and it's my privilege to bore you about React Native Web for the next 40 minutes. If React Native isn't your thing, I think that there's currently a talk about writing responsive applications in Flutter over on the junior channel. I think Blessing's given that. So you've still got time to join if this doesn't sound like what you're into. And additionally, this talk was originally designed to last about an hour, so hopefully we can manage to cram it into 40 minutes, but I'm not going to make any promises. So let's just get started. So as we know, React is an extremely versatile and expressive framework for designing web interfaces. And in my understanding, it's because React as a framework is the product of three key things. The first is its continual, genuine challenges to age-old conventions in software development. The second is it really leverages excellent community support and collaboration through open source services. And finally, that rich open source ecosystem which comprises the software provides us with unparalleled levels of tooling. The paradigm of components, props, and state has proven such an effective model for composing front end that we now find implementations of React that's in platforms that stretch far beyond the web. So the most prominent example of this is React Native, where the React team basically taught the mobile industry that implementing performance, scalable mobile applications with native performance doesn't actually necessitate all of the low-level programming with traditional comparably restrictive languages. And recently, React Native has even stepped out of the confines of mobile devices and has begun to support environments, like desktop environments like macOS and Windows. And this is all just one language, right? But there are other implementations of React which emphasize the abstract nature of front-end specification even further. For example, take React Inc., where you can use React to traditionally, you can design traditionally quite complex and low-level command line interfaces with the ease of conventional scripting. And even this presentation is written in React. So React Native is like a generalization of React. It has the same exact utility and sort of broad level of use cases, except it just employs the use of various abstractions to help us decouple away from the DOM. So what I mean by this is, for example, a div will become a view, span will become a text, and I don't think I've ever said this one out loud, img, I don't know, it becomes an image, that kind of thing. In this regard, it's only natural that React Native can actually be turned back in on itself to once again target a web page. The web is just a specific view implementation of the top-level generic API, after all. Now, imagine the increase in productivity that this affords us. You get to stress your codes and layouts on multiple different devices and different operating systems. And therefore, the value of your features and the value of your product actually scales proportionally with the number of platforms you have the explicit intention of supporting. React Native is truly what it means to write once and run anywhere. Hi. My name is Corfrey, and I'm apparently the React Native zealot. I don't even know how. So anyway, I've been developing in React Native for around 3-4 years now. And in my time, I've probably published over 100 React Native open source packages. So it's fair to say I'm a little bit obsessed with this platform. What a lot of people don't actually know about me is that I used to be a PhD student, and I used to study cross-platform computing. So I have a particular sick interest into the approach to, I suppose, general computation that has been achieved by the React Native team when it comes to simply expressing abstract computation or front-end specification in a way that can run on multiple different platforms. Now, presently, I'm one of the founders of Myco. We're a community-owned platform where we launch new co's. And a co is something like a community, a collective, a cooperative, or even a corporation. And we deliver built-in incentives for revenue generation to provide communities with a genuine ownership and an actual stake in their success. And this is all powered through cryptocurrency via the Ethereum blockchain. Now, we currently use a single code base for both Android and iOS, but also the web too, using React Native. So I would hope that that puts me in a fairly good position to talk with you how to deliver truly web-first user experiences in React Native. Now, I'm going to try and cover everything I know in 40 minutes. I understand that we're on the senior track, but I don't much like the idea of just jumping into a project without actually building up some context. So really quickly, I'm going to show us how to just get set up with a React Native web application. We'll get started by looking at how to make a project. So there are two mainstream ways of creating a project. Firstly, you can use npx create React Native web app, which creates the standard vanilla React Native project, which contains all the usual suspects. So you've got your Android directory and your iOS directory, but it also comes with a third directory, your config directory, and this is what houses Webpack configuration, which is effectively used when converting something which originally targets mobile applications into something that can actually be understood and interpreted by a web browser. Alternatively, you can use npx create React Native app to create what is essentially a functionally equivalent project, but with the key difference is that a significant amount of the project infrastructure is actually managed by Expo. Now, Expo is an open source toolchain built on top of React Native. It abstracts away a lot of the low-level complexities that we have to work with when dealing with React Native, but obviously this comes at a cost of control. This is effectively because Expo's primary job is to help you focus on delivery, and it is excellent at doing that. Now, that's not to say that you can't just yarn eject from an Expo managed project to regain access to the fine tuning of your project's configuration. But this isn't really in the spirit of Expo. And besides, nowadays, the support and infrastructure of Expo is so comprehensive that it's uncommon to find yourself needing to do so anymore. So in regard, the standard kind of project creation rules still apply, right? So you can use npx create React Native web app if you wish to achieve sort of complex custom things with the React Native runtime. So a really good test for this, like a sanity check, is if you want to go down this route, is whether or not you can see yourself having to roll your own custom native integrations somewhere down the line. And alternatively, we use npx create React Native app if you plan to leverage either pure JavaScript dependencies or the ever-growing libraries of managed native libraries that are already supported by Expo. So for this talk, I want to have a look at both methods of creation. So we'll probably be able to do a little bit of comparing and contrasting between these a little later on. Now, I know this is the senior track, so I'm sorry I have to do this, but we're going to go for a really, really quick Hello World example, just so that we're all kind of like at the same level of one another. So for me, Hello World in React Native is like a green box, right? So let's quickly do that. So what I'm going to do is go into my part 1 directory, and you can see I've got 3 folders. So I have an Expo folder, a snack folder, and a vanilla folder. Now, Expo contains a project which was made using Create React Native app. And if we look at it and just inspect the folder directory, you'll see it looks like pretty much a standard JavaScript project. There's nothing immediate that would suggest that this is actually a native mobile application, or additionally something that can be run on the web as well. This is sort of the level of complexity that is kind of abstracted away when using Expo. So it makes it really, really simple to get started. Now, alternatively, if we just jump out of here and instead go into the vanilla project directory, this is a project which was created with Create React Native web app. Now, as you can see, it is hugely different, and you can see all of like the native dependencies that we use when we're delivering a native mobile application, and in addition, the config folder, which contains our Webpack configuration. This is essentially the mechanism by which we're able to take one of these native applications and push it over to the web. I'm not going to jump into this in too much detail now because we'll come to it in a little bit. Finally, there's a snack folder as well. It's kind of pointless. It doesn't actually have to be a folder. It's nothing in it. It's just a reminder for me, and it's a reminder to show you guys the snack tool, which can be found at snack.expo.io. And what snack is, it's effectively a fully fledged React Native development environment for Android, iOS, and the web inside your browser for free right away. Like, it is brilliant. So for anyone who's watching, feel free to open up the IDE and follow along with what we're doing and see what you can come up with. So If we were to jump back into our Expo folder really quickly, let's take a look at our Hello World app. So you'll see I've already kind of set this up a little bit. It's not too different from the template, just I've added a green background color because, I don't know, it's like my preference or something. Now to run this project, all I have to do is go into our Expo folder, and I'll just run yarn web. And what this will do is tell Expo that we want to take our application and actually serve it over our web browser. So it will, in the background, spin up the Webpack bundler for us. And while it builds that, it should be fairly quick. It doesn't have to do any native stuff. And there, that's being served. So I should be able to navigate over to the Expo URL on port 1906. And here we are. This is really unimpressive. So don't worry, it will get a little bit more interesting later on. Now, just to show you kind of how this same application translates, right? We can actually spin up a iOS instance of the same project and actually see this project come up on our iOS emulator or Android emulator. But before I do that, let's just make a little customization just to demonstrate that even when we're doing React Native Web, we still have access to all the functionality that we love about React. So, for example, access to hot reloading or fast refresh. So what I will do is inside our React Native import, I'll take an image and I'll just add that to our DOM. And I'll specify a source URI prop. So effectively tell it I want to render an image, and I will steal this URL that I held onto. And we'll also just have to give it a style prop. So I'll give it a width of 100, and then that should be enough to render an image. So if I save those changes, we should see this image get pulled through. And there we go. That's a really, really horrible dimensions I've picked. It probably needs to be a little bit wider. So let's make that 500. Better. You get the point anyway. So now just to demonstrate you that we can run the same application back on an iOS device, I'm just going to stop the bundler and instead run yarn iOS. Now, what's going to happen instead is that Expo, rather than going through Webpack as the utility which is in charge of building this app into something that can be executed, we're going to be using the React Native Metro bundler instead. And what Metro does is essentially takes your JavaScript source files and essentially maps those through calls to the React Native bridge, which can enable you to do like interesting sort of native stuff. It's basically a lot that Paola has already talked about, so I'm probably not going to go into too much detail about that. Now, once our app boots up, you should be able to see that our application should look quite similar. Now, you'll notice that there's a big difference in time it takes to actually run these applications, and the reason is quite frankly that there's a lot more bits that you have to push through effectively when you're trying to actually compile a native application. This is really slow. I might just leave it for a bit. We can carry on. So in fact, maybe I should refresh it. Yeah, okay, so I don't know why that took a refresh, but there you go. So you'll see that our JavaScript bundler is now kind of like churning out our application very slowly. This is actually unusually slowly. Maybe it's because of the demonstration feed stream that we're doing. So we'll just wait a second and let that do. By the way, we call this demo syndrome. Like everything has to go wrong when you're actually demonstrating stuff. I promise this took about like 10 seconds when I was practicing earlier today. Wow, so slow. Now, you know what? Because this is slow, I'm just going to jump right to the surprise. This project actually isn't going to work when we load it because I've done something that we're not really supposed to do. Come on. It feels wrong to jump into it without actually seeing it fail. Okay, there we go. So we've kind of got our cross-platform application. We can see the text, we can see a green background, but we can't actually see the logo that we've used. And this will kind of emphasize that even when we try to do something that's really simple, you can run into cross-platform differences very easily in React. So what is actually going on? If we go back to the example, you'll see that I'm using an image and I've specified a source prop which points to a .svg URL. Now, SVG files, web browser can handle those just fine, but in React Native, there's sort of like no native interpretation of what these files mean. We actually need to tell React Native what the file type is. So instead of using an unsupported asset, we would have to depend on a library which actually can handle SVG files. So for example, I can import the SVG URI component from React Native SVG. And instead of using our image, I will instead use an SVG URI. And I believe this component expects the URI prop to be passed directly. And the same for the width and height too. So I'll say width, let's try and get it a bit better this time. I'll say width 500, and we'll say height. It needed to be a little bit taller, so let's call it, I don't know, 130. We'll get rid of our other image. And if we refresh our application.
Bro, pardon for jumping in, but
oh, sorry, hello.
Yeah, you'll have another additional like 10-15 minutes because I'm trying to grab some questions for the Q&A, so go ahead if you need additional like 10 minutes.
Right,
we'll just
I thought my feed dropped out.
No, I mean, like we'll just bite it off the Q&A section, so you have like another like 25-30 minutes, so go ahead.
I'll try my best. Thank you. Right. That means we can sit through a lot more really slow bundlers, which probably help us out quite a bit. So if we go back to our app, there we go. So we can now see our image come through kind of as expected. But this brings up a really important topic, right? Like, it's very simple to do things which are not going to be compatible right out of the gate. Now, the real reason that this comes about is because there are effectively differences in the way we have to go about implementing certain features when we would do in conventional React Native, or if we were doing a pure React application, for example. And this is because there are differences in whether or not you want to support a native application or support the web. So what do I mean by this? So there are fundamental differences in the way that React Native is effectively structured when we're running on the web. So, for example, a really easy way to kind of interpret these differences is through the import of native modules. So native modules is kind of what we've alluded to earlier. This is the mechanism by which the JavaScript runtime can interact and perform native operations in the native runtime. And this is effectively how React Native applications can do native things and achieve native performance for particularly like computationally difficult operations. Now, the trouble is that this module doesn't actually exist in React Native Web because, you know, when you're developing in React Native Web or in React, it is JavaScript or bust, right? Like there is the browser is the operating environment. There's no way to add sort of native sorts of binaries to the runtime. Of course, you can install extensions, but fundamentally, if we're talking about the app as an isolated instance, you know, there's a limited scope of like functionality that you can really depend on in terms of, you know, custom modifications to the runtime that you operate in. So, for example, the native modules import just won't work in React Native Web. So when you're picking out like certain libraries, any of these libraries which may depend on native modules just aren't going to work in React Native Web. So these are one of these things that you really have to look out for when you're choosing or deciding on which kinds of libraries you actually want to import into your application. So yeah, whenever you see something that's going to be depending on native modules, you just don't want to do that. Now, for things like native modules, for example, if we consider the crypto library, right, in Node, you can't use crypto in React Native. If you try to pull through a Node module, which depends on crypto, you're going to run into compilation errors because it's something that is not supported by the React Native runtime. But by contrast, you know, on the web, we have web crypto. So there are always going to be like minor variations between these libraries that we have to look out for. And there's always ways around these, right? So for example, I've had a lot of success recently because at Myco, we do a lot of things to do with cryptocurrency, especially to do with the Ethereum blockchain. Ethereum is referred to as Web3, and it's a really good name for it because it is mostly a web technology. A lot of the dependencies that we need to do Ethereum aren't really just going to work right out of the gate with React Native. And that mostly comes down to the fact that they depend on the crypto module. But I've recently come across a library which is great. It's called JSRSA sign. And it is like a fully fledged crypto environment. It has all of the functionality and much more that is supported by conventional crypto, which means that it's quite simple to now sort of like fork one of these libraries and actually replace the calls to crypto using JSRSA sign. So a good example of this recently I published was using Twitter Lite. So you'll know that if you want to do do Twitter API calls from React Native, you normally have to roll out a native library to do these things, right? There has to be some native integration. But recently I was able to fork the Twitter Lite package and just replace the calls to crypto, and then it works perfectly inside of React Native. So there's a lot of scope for opportunity for us to interact with these kinds of modules. Now, secondly, another way to get around this kind of I guess missing functionality in the React Native runtime is by shimming. So there's a project called React Native. Oh, what is it? I think it's React Native shim. I've got this wrong. I can't remember. It'll come back to me. Essentially, you can effectively use native node modules in your application, but after the install operation, it basically hacks away. It's rn notify, I remembered. So yeah, you can use rn notify, and it will essentially take all of your node modules directory, iterate through them recursively, and try to decide which changes need to be made in order to force it to expose itself in a way that is portable in React Native. Now, the trouble with this is that shimming is akin to polyfilling, so there's never really any guarantee that the shimmed interface is going to behave precisely in the way that is expected. Because when you're shimming stuff, you're basically hacking away at the code, and you may introduce maybe function signatures might change, for example, just small variations, and you can't promise a consistent interface to any dependent modules because of things like version changes and that sort of thing. So instead of polyfilling dependencies, we should try to ponyfill, because ponies are pretty. A great way to ponyfill applications is with Browserify. One of the things that I found out right before I was right before I started working on this presentation was that browserified modules, so effectively modules of code which are supposed to run in the Node.js runtime, they don't care about being on the browser, they don't care being on React Native. You can push these through Browserify, and it will essentially recompile the application into a form that can be understood by a web browser, right? So that kind of like ticks the box for React Native Web. But the amazing thing about it is that React Native, you can consider it a fork from React, right? So there's this implicit understanding or awareness of what the browser environment looks like, and that actually comes through and is visible when you're doing React Native sort of like runtime stuff. So you can actually use browserified modules in React Native because it exports the same sort of global scope that a browser would have. So you can really, it opens up a lot of possibilities to what kind of dependencies or operations you can start doing. The only drawback to this is the bundle size, because you're effectively having to sort of like re-encode entire Node.js core modules into something that can be ported around. So these can normally be quite big. But recently I found this project called, I think you're supposed to pronounce it Wizardin, but it's wzrd.in. Now what this is it's a CDN, but for browserified modules. So literally you can have these browserified modules served to you. So you don't really have to care about the size of these things, like carrying around and inflating your compiled bundle size anymore. You can just pull them at runtime. And what's amazing about it is that you can go onto this website and you can just search for whatever package it is that you want the browserified equivalent of. And if someone has asked for that package before, you'll get it like instantly. It will just serve it directly to you because will be cached in their file store. Or alternatively, it will browserify it for you on the fly and then give you the URL callback. I should probably show this actually because it is really awesome. So if we go to wizard.in, is our browserify module, and you'll see down here it says you can pick a module that you wish to browserify. So the example it gives you is concat stream. I could choose a different one. I could say base-64, for example. And if we hit go, it will compute the browserified implementation of your library and then serve it to you. So there you go. So this is a real game changer. It's something I've only found recently, but this is really going to change the way that I start to think about the kinds of libraries that are available to React Native. So, for example, recently I worked on a project called Pyongyang, and what Pyongyang did is use the React Native web views to sort of expose these native libraries through a sort of soft like web view bridge, so that you can expose functionality from CDN assets like this to the React Native runtime. So I think we're at the start of something that's going to be quite exciting in the future. So just to go back, yeah, so another thing to look out for when you're trying to find out whether or not a particular module is going to be able to support the React Native runtime is whether it contains these HTML tags. Now, if React Native Web encounters these HTML tags, you're in React Native Web, right? So it implicitly understands, React Web operation, so it'll be able to process these tags just fine. However, if React Native running on Android or iOS were to encounter these tags, they don't actually resolve to anything within the application sort of global scope. There's no components to synthesize, and it'll call an error. So generally speaking, if you see the invocation of like direct HTML blocks within a React Native dependency, it's not going to be compatible with React Native on mobile platforms. That is, of course, if this kind of syntax is scoped within like an if statement, conditional on what is the current operating platform. So let's do another example. So if you're going to support an application which is going to run on Android, iOS, and the web, you're going to come across a lot of instances where you're going to have to mix different imports together. So we can ground this in an example which is kind of similar to the thread we've been talking about web views, right? So there are many instances where you may actually want to render a web view on React Native Web. That might sound weird because we're already in a browser, but I like to think of it as we have iframes in React or in HTML, right? There are some times where you have to delegate some aspect of the user journey, either from a UX perspective or maybe even from a business logic perspective, to these external sources. And the same thing happens in native applications, because we can not only use browsers the web view to sort of render external third-party content maybe, or point someone to a website for troubleshooting, but also it has quite interesting applications. For example, as I explained with Pyongyang, where we can actually get the web view to actually crunch some weird kind of like crazy JavaScript for us away from the React Native thread, but still on the UI thread. Now, to give you an example of this, I'll just jump over to our next directory. I hate this URL structure, by the way. It's really tedious. So in this project, you will see that I've, if I want to use a web view in both React Native and React Native Web, there's two libraries that I have to use. So I have to use React Native Web View for mobile, so Android and iOS, and React Native Web View when running on the web. Now, there's a few ways we can go about doing this, right? So the easiest way would be I've got the platform imported, so I could import both of these web views, and I'll say I'll import web view as native web view, and I could import the web view from React Native web view as web view. And then at runtime, I could say const selected web view is equal to platform.select, which is like a almost like a it's like a variable initializer mixed with a switch statement. So I could say for iOS, I want to use the native web view. I could say I want to use the same for Android. And then for the web, I will say I want to use the web view. So at runtime, React Native will iterate through this statement and decide, well, if I'm running on iOS, I can use the native component, or if I'm on the web, I'll use the web version of the library instead. And provided these components all export, the same interface to the caller, which in this case they do, then you're not really going to run into any problems. So let's just show that now. So I could say I can take my selected web view, and then inside of my project, I can just say I want to render my selected web view, and I want to give it a source prop with some HTML. Inside my HTML, I'll say hello world, just to demonstrate how amazing my HTML skills are. And then, of course, to render sort of like static HTML like this, you actually have to specify that you want to use an origin whitelist as well. This is more like it accounts for security concerns about where particular content can be loaded on. So from this case, I'm actually saying I don't really care for this HTML. It's only ever going to be the HTML which is served from my my source code here, and that would work, right? But if we look at this, there's kind of an issue with it, right? So you'll know that when React Native or React Native Web has to process this module, it comes across both imports, right? Regardless of whether or not we're actually going to use one, because it needs both of these dependencies to get to the platform.select statement. So we're effectively for the web or for the mobile, we're carrying around dependencies that we're actually not ever going to really need. You only want the native web view on native platforms. You only want the web view when you're on React Native Web. There's no need to have both at the same time. So we're not only increasing our bundle size when this is compiled because we're saying we need both of these things, but we're also kind of making it more difficult to maintain because you don't want to really have to do this sort of conditional logic everywhere. And possibly worst of all is that in this example where we're using React Native Web View and React Native Web View, both of these libraries actually behave pretty well. You could import both of these on the web or on native platforms, and you're not going to throw an error. But that's not always going to be the case because there are a lot of native modules that we'll need, which will actually attempt to perform some kind of initialization when you import them. And since native modules doesn't exist on the web, that would actually cause an error. So you actually do want to try and avoid this kind of implementation of like a platform specific selection of component to render. So a way around this is actually I could make a new directory called WebView, and inside WebView I'll make three files. So I'll call this one index.ios.js, index.android.js, and index.web.js. You're probably going to guess what's going to happen here, right? So inside each of these components, I can effectively make, I will pull in our dependencies. So where am I? I think I'm in the iOS file. So, oh wait, I don't even think let's try that again. If I go into index.ios.js, I can choose to export the web view from React Native Web View as the default export. And in the Android library, I can also pull in the same export as well. So both of these files are now going to just export the native web view. And finally, I will take our web view export, and I'll paste that in our web file and make this web compatible web view the default export. Now, what happens here is kind of interesting. So inside our app.js, instead of doing this weird stuff that you really want to try and avoid, I can just import my web view from .-webview. And you might be kind of surprised, right, that this actually looks a bit like a component, even though we're referring to a folder now. And either the Metro bundler or Webpack is going to be smart enough to determine which component is actually going to be required based on what platform we're actually building from, which means that we're going to reduce our bundle size, and also we're going to just improve the overall maintainability of the project. So for example, you don't have to do this switch statement everywhere. You can just depend on dedicated components, and because the component instantiations themselves are separated by the runtime, it means that if there's any runtime specific hacks that you might need to do, you can just for example, to make them export the expected interface that is required depending on specific runtime, so that you can have a common way or a common mode of operation regardless of where you are in your application, then you can make those changes in the platform dedicated file. So it makes things a lot easier. I could run this. It's kind of boring, but we should probably give it a go because I'm not sure you guys will believe me if I don't run it. So I will use our web view there, and I'll very quickly. And I hope it's going to be quick because the bundling time has taken ages so far. So we're going to part 2 into my web view. I'll quickly run yarn web, and hopefully that should take a couple of seconds. In the meantime, are there any questions anyone has? No? Oh wow, can you guys hear that? I'm gonna drop that tab. Right. So hopefully, yep, our application's bundled. So now if I head over to our URL, you will know it still hasn't finished. You know what? It's never been this slow. It must be the stream. It must be this amazing quality HD stream. So if we run the application now, you'll see there we go. So we've got our HTML running in our web browser, and the Webpack has been smart enough to essentially leave out our calls to React Native Web View in this case. And if I ran this on native platforms, you'd see vice versa. So ugly example, but interesting technique, right? So let's move on. Now, another thing which is really important to touch on, and it's kind of what we've sort of just demonstrated with the fact that not only can bundlers actually interpret different files as them being responsible for or not. So I just closed that. But also there are actually entire different ways in which they work as a whole. So let's switch our project and go to part 3. By the way, before I continue, I just want to check how much time we've got. I've been talking that long. So inside this project, we have a different application this time. It looks really complicated, but we don't have to worry about it. The only obvious thing is that we have this masonry layout thing at the bottom. So it's essentially we want to draw some kind of Pinterest style board somewhere, right? Now, if I run this project, so we'll do yarn web again. This project's not going to work out of the box. And for anyone who's used React Native Web for even an hour and tried to pull in some web dependencies, I will guarantee you've probably seen this exception before. So it says it failed to compile. And if you've seen these errors enough, it's pointing at the beginning of a JSX tag, which implies that it doesn't understand how JSX works, which is weird, right? Because this scroll component here exists in a React Native masonry import. And it doesn't say that it's dying on this line, which means that obviously the app can understand JSX, but for some reason it doesn't actually understand this component. Now, the reason for that is, in fact, I should probably elaborate before we go on. This same project will actually work absolutely fine on native platforms. You won't see this error, and it'll work as expected. Now, the reason that this happens is because there are fundamental differences in the bundlers. Now, the React Native bundler is greedy, so it will recurse through your entire node modules directory and apply Babel transforms to convert JSX syntax into something that can be executed as a sort of plain kind of commons JS stuff, right? But React Native Web doesn't do that, and we can prove it. If we go into our config directory, which is where our Webpack config lives, I can jump down to where Babel files are processed, and you will see that this step, which uses Babel Loader, the thing which can understand things like JSX and convert them into just standard plain JavaScript, it only actually looks for our application source directory and nothing else, which means that if you include a dependency which hasn't been pre-processed, it's not going to process it for you. So a really quick workaround for this is I can, instead of just including a single app source, I can also tell it to path.resolve from our current directory, and we'll say node modules. I think it's one of my terrible dependencies, so -core3 -react native masonry. Now that would fix it for just this dependency, but often you don't really want to do this for all of them. So you could alternatively just say path.resolve from the current directory and then node modules, and then it will process the entire node modules directory for you. But then we kind of run it into long bundler times, like we've seen when we did the Expo example. It would take a lot longer to do these kinds of demonstrations. So just to show you that this actually fixes it, I'll stop Webpack and restart it. Unfortunately, we can't rely on hot reloading changes for Webpack because, in my understanding, Webpack is the mechanism by which we declare that hot reloading is a thing. And there we go. So now our application works as expected. Pavel, have I talking too long? Should I keep going? I think Pavel's not even here. I'll keep talking. So that fixes that problem. So it's one of those things to look out, I suppose. And that brings us over to part 4. I feel like I'm going to have to rush this last one, so we'll do it really quickly. I guess I can pick between these 2 examples. I think I'll go with styling. Now, when we're talking about targeting the web, when we think about web applications, right, what do we think of? We think of things like CSS or SCSS or Sass, right? Now, React Native doesn't depend on CSS to define things like layout. It depends on a built-in export called the style sheet. Now, the style sheet is quite interesting because it is not only the way in which we can sort of define essentially CSS and JS, like the same way in which we declare the style prop, for example, but it also has some very useful properties to do with performance enhancement. So you'll probably see in a lot of React Native examples where they seem to be using the style sheet object and doing things. For example, they'll say const styles is equal to style sheet dot create, and they'll probably call something container, and they will take some style like this and they'll put it in our container, and then they'll refer to the style as styles.container instead. Now, you might wonder why they do this, because that's a lot of work just to handle styling information. But the trick is that style sheet actually does a lot of upfront work in pre-processing style information so that you don't have to process it every single time. Now, this isn't just the same way, that, if we declare, for example, a style prop in line, React shallowly compares things, right? So it's going to see a newly allocated object every time. So even if we just say, flex1, we think that it deep equals whatever the last render style was, but React is smarter than us. It can tell that the object has changed. So not only can the style sheet help us kind of like deviate away from these difficulties in performance, but also it means that we don't actually have to continue processing these operations as well. It's like once you've pre-processed the style, that's it. You don't have to do it anymore. So you might be quite interested to realize that actually when we say our styles is equal to styles.container, we're not actually returning an object, we're returning an integer, and that integer effectively points to some allocated resource, which is your pre-processed style. Now, this might look really good, but it gets kind of difficult when we want to do dynamic styling, right? Because how do we do anything dynamic with this kind of like fixed allocated resource? The truth is you can't, but you can append styles to one another. So for example, the style attribute can actually be an array as well. So not only can I take advantage of pre-processed, it'd be great if I learned to type. Not only can we take advantage of pre-processed styles, but if we want to do anything else, which is maybe dynamic, let's just do that for now. And by using array, we can mix efficiently delegated style information and also kind of like runtime information too. It's important to note that because we use an array, it also respects the order of precedence that these items are declared. So for example, if our styles.container contained a background color, we would have overwritten it with red. Now, a really important thing to know about when we're handling style information in array is that if your component accepts a style prop, for example, you can use that style inside the array, kind of like as you'd expect. So now we're adding the default container style, and then we're saying whatever style the call has provided is able to override those properties, but not the background color. Now, the problem with doing this is that it's useful for callers to be able to have the same kind of array declaration of style information so that they can mix efficiently pre-processed styles with dynamic attributes too. But the trouble is that if that style is an array, you can't have a deeply nested array of styles. So what I mean is that if this style was, like some iterable array, this can't actually work as style information. Now, we're in luck because the style sheet actually has a way to normalize style information. So regardless of what the user prop passes you, or should I say the caller's prop gives you, even if it's undefined, even if it's an object, even if it's another, style sheet integer, we can make a call to style sheet.flatten, and this will basically normalize the attribute so that it can become compatible in an array declaration, and they'll essentially get flattened into the single element so that they can just get processed normally. So whatever you do, whenever you're accepting style information from one of your components and you're mixing it with an array of styles, you must always flatten it. Otherwise, it's just going to cause runtime errors. Right. Pavel, did I talk for way too long?
It was good. Sorry, bro. I heard like you were calling me, but pardon.
I'm so sorry.
I went like to take a leak. I mean,
I just gotta let you guys know that there's a bunch more information on those slides, because I mean we knew it wasn't going to work anyway. Like, it's an hour presentation, so we just tried to pack it in. But if anyone's interested, you can find this presentation on github.com/corefree, and yeah, feel free to kind of go through it, because there's a bunch more interesting examples there.
yeah, and we have guys with us, so I guess maybe if they have any questions, and they can ask you definitely, and you can ask them.
Yeah,
Because
that sounds good.